Okay, this video will help with chapter 14, specifically 14.1, where you have to predict the ending to the electron configuration. So the first thing I would do is I would label, there's kind of 4 anchors you want to know. You want to know that hydrogen ends with 1s1, and you want to know that boron ends with 2p1, and that scandium ends with 3d1. And for completeness, I'll say the first inner transition metal is going to be 4f1. There's some problems here with where the inner transition metals start and which elements actually down here, so I'm going to put 4f1 and overlook the names down here and probably not do a lot with it. Now that we have our 4 anchors, we can look specifically at certain elements. So for instance, sodium. If I'm looking at sodium and I'm trying to figure out how he will end, I want to look. I have 1s1. This would be 2s1. I'm going to circle my anchors. These 4 circled ones should be memorized. And then this one would be 3s1. Now, if I wanted to come over here and look at strontium, for example, I would look and say, okay, if this is 1s1, then going down 2s1, 3s1, 4s1, 5s1 for rubidium, but the column to the right would be 5s2. So strontium would end with 5s2. So I'm just following patterns. Another one I would look at is aluminum. If I'm looking at aluminum, he's in the P block. Let me go ahead and label those. Over here, these 2 columns would be called the S block. These 6 columns would be called the P block. And then the transition metals make up the D block, and the inner transition metals make up the F block. So for aluminum, he's part of the P block, so I know it's going to end with a P. He's the first column of the P block, so I know it will be P1. If boron's 2p1, then aluminum would be 3p1. Let's try a different one. Let's try xenon. How would xenon end? Well, he's in the P block. He's in the 1, 2, 3, 4, 5, 6th column of the P block. And if boron's 2p, 3p, 4p, 5p, he would be in the 5th energy level, P sublevel, with 6 electrons. Now I'm going to go ahead and do a couple of the of the transition metals. Vanadium is in the D block. He's in the 1st, 2nd, 3rd column. And then if scandium's 3D and vanadium's in the same period, he would also be 3D. So vanadium's 3D3. And you could do it longhand and it would end with 3D3. Now this transition metal, mercury, he's on the right of this mess. So I'm going to do him a smidge differently. I know he's in the D block. And if scandium's energy level 3, then yttrium's 4, and mercury must be 5. But I know that this is D10, so I'm going to start from the right. So this is D10, D9, D8, D7. That way I'm not basing anything off that mess, because it's going to depend on who your teacher is and which periodic table you're currently using. And that's how I would predict the ending to the last orbital diagram.